Let's move on to example 4 of solving trig equations. We have 2 sine squared of theta is equal to 2 plus cosine of 2 theta. So there's a couple things going on that we need to notice. First of all, we have two different trig functions. We have a sine and a cosine. That's okay. We can still use those 9 easy steps to solve this. We also have a theta inside of these parentheses and a 2 theta here. Remember, you want to try to get in terms of one angle and one single trig function. The question is, what is theta? And this time the domain starts at a negative angle, negative pi over 2, and goes to pi over 2. So keep that in mind. Theta needs to be in between these two values or at the endpoints. Step 1 is to move all the trig functions to the same side. So what we're going to do, again, this is the same steps we've been doing in the previous problems. We're going to subtract cosine from both sides. Now we do not need to subtract the 2 because it is not a trig function. This step says to just move all the trig functions to the same side. So I'm going to subtract cosine of 2 theta from both sides. Let me go ahead and underline that. And we are left with 2 sine squared theta minus cosine 2 theta is equal to 2. So at this point, what are you going to do? You've got two trig functions and you've got a theta and a 2 theta. Well, not to worry. We're going to go ahead and move to step 2, which is write all the trig function in terms of the same angle, preferably a single angle. So notice that this is a double angle, and we can use the double angle formula to simplify, and we can write it in terms of sine using the double angle formula. So recall that cosine of 2 theta is equal to 1 minus 2 sine squared theta, and guess what we've done? We've eliminated the 2 theta to just theta. Of course, we have this as well. And we've also got one single trig function. They're both in terms of sine. So we knocked out step 2 and step 3 basically in one single step using the double angle formula. Namely, if possible, convert all the trig functions into the same function when you use the double angle formula. So this is, we have sine only now in our formula. So we can move on to step 4. Step 4 is to replace the trig function with a variable. So we're going to replace sine, not sine squared. You don't include the exponent, okay? Just the sine. Sine of theta is equal to x. Okay, so then this everywhere there's a sign, we're going to replace it with x. And let's see if I can do this. So it's going to be 2x squared, and I'm not simplifying anything at all. Minus quantity 1 minus 2, and then again the sign is replaced with x squared is equal to 2. So we can see when we do step 4, when we replace the trig function with a variable, it looks a lot more like an algebra problem, and it's just more manageable. So now we're going to solve for the variable using algebra. First things first, distribute the minus to both of these. In fact, let me draw an arrow there. So it's going to become minus 1 and then plus 2x squared. Okay, so 2x squared minus 1 plus 1. Let me make sure I have this right. That doesn't look right. Let me make sure I did my math right. I'll be right back. Okay, I know what I was doing. I was adding 1 to both sides. So let's go ahead and underline that. Yes. We're moving this minus 1 to the other side. So another way to show that, which perhaps doesn't confuse you, is to move it over. Just make sure you add it. So you get 3 on the right, and then you're left with 2x squared and 2x squared on the left. And if you add those up, you get 4x squared. So we have 4x squared is equal to 3. Next, we're going to divide by 4 and take the square root. Divide by 4, take the square root. The square root of 3 is square root of 3, but the bottom becomes 2. And because we took the square root, don't forget, every time you take the square root, to put plus or minus. So we have x is equal to plus or minus the square root of 3 over 2. Awesome. Now we're going to replace the variable with the trig function, since that's what we're doing. We're solving a trig equation. So step 6, replace a variable with trig function. X, we said, was sine of theta, so x is replaced with sine of theta. And if you forgot that, we did that in step 4. Sine of theta is replaced with x. So now that we've solved for x, we're going to replace x with sine of theta, since x is equal to sine of theta. Okay. So we got x is equal to plus or minus square root of 3 over 2. So sine of theta is equal to plus or minus square root of 3 over 2. We're going to take the inverse of both sides for step 7, as we always do. So sine inverse on the left, sine inverse on the right. Again, we do that because the sine inverse cancels the sine, and you're just left with theta on the left. And of course, we can figure this out using the unit circle. So theta is equal to sine inverse of plus or minus square root of 3 over 2. Step 8, we're going to solve for the angle. So here's the question, and let's just go ahead and draw the unit circle out. Now remember what the original domain was. Original domain, we want it to be between negative pi over 2 and pi over 2. So where is that on the unit circle? Well, here is negative pi over 2, and if you swing on up, you get to pi over 2. We can see that's 180 degrees, starting with negative angles. And so the question is, where does sine equal negative square root of 3 over 2 and positive square root of 3 over 2? Well, it equals negative square root of 3 over 2 at this angle, which would be negative pi over 3, and it's equal to positive square root of 3 over 2 at this angle, which would be positive pi over 3. So therefore, theta is equal to negative pi over 3 and positive pi over 3. It's very simple. So that's step 8, solving for the angle. Last step is to check our work. Okay, so I went ahead and checked by plugging in negative pi over 3 into both sides of the equation. We just showed that sine of negative pi over 3 is negative square root of 3 over 2. In fact, we did the reverse, so we're going to replace it with that. And on the right, we can see that we get cosine of, so we're replacing theta with negative pi over 3 since that's what we got. On the right, we're going to be multiplying this, so we get negative 2 pi over 3. Now we square this on the left, we're going to get, it's negative, so it becomes positive. Square root of 3 squared is 3, and 2 squared is 4 on the bottom. And on the right, what is cosine of negative 2 pi over 3? Well, remember that negative 2 pi over 3, let's use purple. Negative 2 pi over 3 is going to be right here, and cosine is going to be negative 1/2 there. Okay, so we can replace that. We can replace cosine of negative 2 pi over 3 with negative 1/2. On the left, we have 2 times 3 over 4. On the right, we have 2 plus negative 1/2. 2 plus negative 1/2 is 3/2, and on the left, the 2 and the 4 cancel to make a 2 on the bottom, so indeed 3/2 equals 3/2. So we know that negative pi over 3 works. Now let's try pi over 3. Okay, so when we plug in pi over 3 for theta, we actually get exactly the same work written out. And it's exactly the same process. On the right, we get 3 pi over 2, and on the left, we get 3 pi over 2. Just want to finish showing these steps here. Okay, and that's because cosine of 2 pi over 3 is also negative 1/2. Cosine of, or 2 pi over 3 is right here on the unit circle, and you're still going to get negative 1/2. And if you look at working out the left-hand side, it's exactly the same that we did when we plugged in negative pi over 3. You get exactly the same thing on the left. Okay, so you get 3/2 equals 3/2. So when you plug in pi over 3 and simplify it, you get 3/2 on both sides. So pi over 3 also works. So I can be for certain and go ahead and circle that, and that's my final answer for solving this equation. Theta is equal to negative pi over 3 and pi over 3. That's it for this example. If you have any other questions about it, let me know.